So my name is Nick Hodges. I'm the developer advocate at Rollbar, and I'm going to talk to you today about building self-healing systems and how they work and how you can use some tools to build some systems that actually fix themselves if, in some basic ways. So this is a little bit about me. As I said, I'm a developer advocate at a company called Rollbar. We provide continuous code improvement and error tracking, things like that. I'm a longtime software developer and development manager, been a member of the Philly.net group for about 10 years now. Been speaking a number of times here at Philly Code Camp and stuff, so it's a lot of fun. I'm a former naval intelligence officer, did that for 12 years, and I'm here to tell you that it's about 42 times more boring than they actually show it on the TV or in the movies or whatever. And one of my culinary obsessions is pistachio nuts. My brother, dad, and I used to watch Minnesota Vikings football games and eat pistachio nuts by the pound. So don't get between me and the pistachio nut bowl would be a good piece of advice. So just real quick about Rollbar, our mission is to help developers build software quickly and painlessly. We like to do that by improving the debugging process. Our values are honesty, transparency, pragmatism, and dependability. So please make sure you hold me to those if you see me violating them. So we're going to talk about self-healing systems today. And as a note, the talk's only about 20 minutes long, so 25 minutes long. So feel free to jump in, ask questions, ask me anything you want. Jump in the chat. I think I've got that part figured out. Let me see real quick. Where is my chat window? Don't see it. Oh, there it is. Recording has started. All right, good. I can see the chat and I can talk to you guys. So a self-healing system, here's a definition that I've kind of put together based on some various spots around the internet that I've looked up what the definition of a self-healing system was. And that's just basically a system that can recognize that it's not working and without any external assistance from a human being, make adjustments to restore itself to normal operation. And of course, that means restore itself to normal operation doesn't mean fixing the bug itself. Actually, what it means really ultimately is either turning off or rolling back, turning off specific features using feature flags or rolling back to a known good state using a previous version. But if you can have a system that does that automatically based upon some critical error that you receive, it can save you phone calls at 2 o'clock in the morning to your team and make developers and DevOps folks very happy if you can avoid that. So a self-healing system needs a few things. It needs to always be up. If it's not always up, then there's no point in having it self-heal. If it comes down to be fixed, then obviously it's not a self-healing system. It needs to be up and running at all times. It needs to have some way to repair itself without going down. You need to be able to monitor it very closely, of course, because if you don't know that there's a problem, then you can't heal yourself. So one of the things that we do at Rollbar is provide that very high speed, very immediate error detection and reporting. And I'll talk a little bit about how that works and how that can work a little later. And of course, you have to have some type of restoration mechanism. You have to have a way for the system to fix itself, as I said, either by turning off a feature flag or rolling back on to a previous known good state. So there's three levels of healing a system that I'll talk about. One is manual changes, i.e. you get a bug report from a customer, you investigate, you fix the bug, and you deploy a new version as a result. All of that happens manually. Nothing is automated. The next step would be something along the lines of automation plus some manual intervention. Perhaps there's an automated system that reports to you that there's an error. It lets you know there's a problem, and then you manually discover and pour over a log file or something like that, manually fix the bug and deploy again. And then the third level would be a fully automated system, whereby a fully self-healing, a fully automated system, whereby an error is reported, the system sees that error, recognizes that it's a critical error resulting in a problem that needs to be fixed immediately. And by fixed, I mean getting the system back to a known working state. And it automatically can do that either rolling back or turning off a feature flag. So a self-healing system needs a bunch of different things. The first thing it needs is the ability to deploy to any server. You need to be able to deploy a new version out to a cattle server, not pet server. If you understand the cattle versus pets metaphor, pet servers are ones that you have and you name and you manage yourself, you feed it, you care for it. Cattle server is one that's out there in the cloud, where you don't care so much about the individual servers, but you just care about the cattle, the herd of servers, if you will. So you need to be able to deploy to any server in order to be self-healing, because sometimes you need to take one of the servers down and put another server back up behind a load balancer, for instance, in order to be self-healing. So that's one thing that you need to be able to do. Next thing you need to be able to do is to deploy without downtime, as I talked about. And that's typically done through some type of blue-green deployment, where you have a set of servers that are have the old version on it and they're running. You take them down, you load up a new set of servers with the new version on it, the blue ones and the green ones. You turn the blue ones off and turn the green ones on at the very same moment so that the new system can start running immediately without any downtime at all. You need to be able to do that. Otherwise, again, the system can't really self-heal if it's going to be down. You also need the ability to monitor hardware needs. For instance, you need the ability to say, I just ran a Super Bowl ad and I need to spin up a few more servers, maybe a few hundred servers or whatever, depending upon how successful your Super Bowl ad was. And you need to be able to do that dynamically, dynamically adjust the amount of hardware that you've put towards your system on an as-needed basis in order to respond to demand and for your services. Fourth, you need the ability to monitor those services in real time and react to failure. You need to have the ability to react to the chaos that can happen when some system goes down or one of the services that you rely on goes down. You need to be able to deal with all of those things in real time. And also, you need to be able to accept those failures and deal with them in a way that your system doesn't go down and doesn't stop working. Finally, you need to, I say that you need the ability to what I call predict the future and take proactive actions. This kind of relates back to maybe monitoring hardware needs or traffic needs on your system. For instance, if you've got historical data that shows that every Monday morning at 9 o'clock Eastern time, your system starts building up to a peak at some time later in the middle of the afternoon, you need to be able to adjust your hardware needs or maybe your traffic bandwidth needs and whatever. You need to be able to adjust those things and take a proactive action to head off any problems that may occur because of excessive traffic that starts occurring at specific times of the week or times of the day. So there's a common theme here through both the problem that we've sort of described, which is trying to keep your system up and fixing itself, and the solution that you would provide in order to do that, and that is error tracking. Error tracking is critical to all of this, because if you don't recognize that there's a problem, you can't heal, and you can't self-heal. And of course, errors are everywhere. There are errors that occur in our SaaS applications in particular that are constantly occurring. Sometimes there are errors that we don't care about or we don't need to monitor. Sometimes there's exceptions that are just informative. And sometimes there are errors that are critical that need to be dealt with immediately. That need to be something that rolls back almost immediately. And sometimes without human intervention. That's where self-healing systems come in, right? You want a system that if a critical error occurs, it can roll itself back automatically hopefully before many or any customers recognize that something's even wrong. And if your system can do that, there's a number of different benefits. One, your customers don't see the error. They go back to a good state before they actually see an error. And two, as I mentioned earlier, you don't get somebody up at 2 o'clock in the morning because the error is occurring on the other side of the earth. So these error signals are the most important thing that happen out there. I'm old enough to remember when Christmas lights would look like this and had a the bulbs were all set in series so that if one of the bulbs burned out, a whole string of lights wouldn't work. Now that's an error signal, but it's not a very good one, right? It's a system that doesn't provide you with a whole lot of information about exactly what's wrong, but it does provide you with a signal that there is some error there. But there's a lot of noise because the other bulbs are all good, but some bulb is bad, and heaven forbid that two bulbs are bad at the same time. You'll never get that figured out. It's a real bad problem. But that is an error signal that we often get in the real world, right? It's just something's wrong, but we are not sure what it is. The system isn't performing, but we don't know why. A slightly better system of errors is the heater, the heat gauge on your car, right? Your car overheats, the heat gauge will go up and gets hot. Now, that narrows the problem down to another number of different problems. For instance, if your car overheats, it probably isn't an electrical system problem, but it might be, but it probably isn't. So a car getting hot, too hot, does give you some type of information and direction as to where you need to go in order to find the problem. But again, an imprecise, imperfect solution or a method of finding out what the error is. An easier way to figure out is some type of circuit breaker system where you have a problem that occurs and a circuit breaker goes off. For instance, in your house, right? If you plug too many things into your one single socket, like I have down here under my desk, I probably have 20 things plugged in, and I plug in 21, that becomes too much for the circuit to handle. The circuit breaker will pop. I can go to my board on my closet here in my apartment and see that the circuit breaker popped, and I know exactly what the problem is. There's too much load on a given circuit, and that circuit breaker will tell you exactly what is the problem. And that's the kind of solution that you really want to get to, is a circuit breaker solution. Because this is the problem we see, right? For instance, here's a graph of web transaction time, and you can notice that everything's going along great, less than half a second, and all of a sudden, boom, out of nowhere, your web transaction times are taking a lot longer. You don't know what happened. You don't know why it happened, but you see that it did. And now you have to start correlating between what time did this thing happen. It looked like about 11:05 or something like that in the morning. What happened at 11:05? Did we deploy a new version? Oh, we did. Oh, what's wrong with that new version? I don't know. I'll have to start poring over the log files. All kinds of things happen that make it very difficult for you to use the limited error tracking information that you have in order to figure out what's going on, what's wrong. So here's the problem, right? Traditional monitoring doesn't give you enough to know and respond to the massive amount of machine data. I mean, and nobody likes to pore over a log file, tracking errors, trying to correlate, trying to figure out exactly what time things happened, when they happened, what was going on. So we need a better way to see where things are at errors. And in order for us to have a self-healing system, we need to be able to have the system recognize that there's a problem itself as well. So if you can't see the problem and you can't understand the problem, you can't auto-respond to the problem. So let me step back a little bit and talk a little bit about how developers used to work. Back when I was a young pup, we used the waterfall method. We manufactured our software. We perfected it before release, right? We had to make it perfect before release because we signed off on that gold floppy or the gold CD. And we did all of our changes before we released our software. And we sought perfection via compiled languages, unit testing, proper QA, all kinds of things like that. We had to fix every bug we could fix before we had a ship date. But now things are a lot different. We're much more agile. With the advent of SaaS solutions, websites that are or mobile applications that use a SaaS solution, you never get done. You're never finished with the process. You're continuously improving. You're continuously releasing. Companies like Amazon release 20,000 times a day or something like that. Some absurd amount of times per day that Amazon releases new, fixed, or improved software. You're never really done. The process encourages change, actually. You fix the bugs that matter at the time, and you can roll back and roll forward quite quickly. So an automated release process, automated CI/CD process, all allow you to very quickly move forward with new changes and new things. So those error signals become very, very important as you move so quickly. So the problem, of course, is that these errors come in and they're all different. Well, they're all unique errors, excuse me, but somehow they map to each other in such a way that the errors maybe are coming in such a, and you don't know what they are. You can't look at the log file and necessarily correlate error A versus error B and how they might fit together. So what you want is a solution that, say, takes the errors, moves them onto a normal log file, but then processes those errors and allows them to be correlated to each other through some type of fingerprinting system or some type of system that says, you know, this error is the same as that error. The only difference is the line of code that it was, or the wording of the error message was slightly different, or things like that. Also, certain errors are new, some errors are reactivated, some errors have been resolved, and some errors are just informational. So you want to know that. You want to be able to pull all that together. And this is where my pitch for my company Rollbar comes in, because Rollbar sees your errors, classifies them, fingerprints them, and puts them together and groups them into single errors. So for instance, if you do a new deployment and you have an error that's occurring when people try and make a payment on your application, you want to know about that immediately. And you want to see that in a unique fashion as a critical error. And Rollbar allows you to see your specific critical errors, and it even allows you to do things like determine that an error is critical. Rollbar will classify the error. You can define in Rollbar specific types of errors that come through that would be labeled as critical. So if you have an exception that's being raised, for instance, in your code because something is broken and people can't pay, or the system isn't working according to how it wants to, Rollbar can determine that. And then Rollbar can even allow you to roll back. We work with your versions. We know about different versions of your application, and we can actually automatically roll back to its previous version and tell your CI/CD system to deploy a previous version. We work with systems like Launch Darkly for feature flags to allow you to turn a feature flag off immediately if it's determined that particular feature is causing the problem. In other words, we allow for you to have self-healing systems. We recognize and group the errors together to recognize them as specific errors and know that any given error is the kind of error that you want to automatically roll back. And we can send a message out to Slack or send you an email so that when you wake up in the morning, you can look down and say, oh my, the deployment didn't quite make it all the way around the world, because by the time we deployed in Wednesday afternoon here in the States. But then when it rolled around, then we came across the kanji edition in Japan or something like that. That caused an error while we were all sleeping, rolled the system back automatically and didn't wake anybody up. And then you can deal with that kind of system the next day. And that's the beauty of self-healing systems. So in summary, self-healing systems are possible. They're very doable. They'll only get more capable moving forward. As you've seen, we've got the basic ability to roll back on errors. It would be interesting to find different ways that systems could self-heal as we move forward. The key to all of this, of course, is tracking and learning about the proper errors and categorizing errors as problems, not problems, critical errors, non-critical errors. And my company Rollbar does all of that. And so I am done. That took about 20 minutes, as I said. I thank you for your attention, and I'm more than happy to answer any questions that you may have.
Nick, this is Joe. Can you hear me?
Yes, I can.
Okay. I do have a question. You did give a great speech here. Thank you. Okay. If you were talking about rollback. Okay. If events occurred, and I'm sure your system knows. Okay, I hit this set of circumstances. I have to roll back. Does your system take a snapshot or collect relevant information? So, okay, I did roll back, I'm fine, but I need to kind of know exactly what caused the problem.
Yes. The error tracking we do includes all kinds of telemetry information, including a full HTTP stack, the stack frame from your code, where the error occurred, a complete rundown of the HTTP calls that were happening when that ends, and the state of the machine at that particular juncture. Yes, we do that. It's really powerful.
So that's not stored on the server itself, because if you roll back, I'm assuming that information is also stored in the cloud or some.
Yes, it's stored on our servers and viewable through our website.
Okay.
And which you would have an account to. Yes.
Okay.
Sure thing.
Thank you.
Sure, of course. Thank you. Anyone else? Appreciate your attendance today. If you want to get a hold of me, you can go to try.rollbar.com/Nick. You can let me know you saw my presentation today, and I'll send you a free t-shirt. So sign up. And if you want to talk to me about anything you heard today, you can sign up with my Calendly link. I am calend.ly, calendly/rollbar Nick. Love to talk to you or chat with you at any time.